Hey guys, welcome to my channel. Today we are discussing about activation functions in deep learning. We know the activation function in the neural network is very important. Okay, so there are several types of activation functions which can be used in different problem statements. With the help of activation function, the neuron will be activated, and the activation function will be used because without activation function we will get a linear equation, like only the weighted sum of the inputs. So there is no use for that since we are using the neural network for solving the complex problem, so we need some non-linear equation. Okay, some of the activation functions were Sigmoid, Tanh, ReLU, Leaky ReLU, Softmax. Okay, let's discuss about the sigmoid activation function, and the distribution of the sigmoid activation function looks like this. Okay, an S-shaped curve. Okay, you can see here, and the output ranges from 0 to 1 for the sigmoid activation function. If the output is greater than or equal to 0.5, let's suppose take an example of a student pass or fail. Okay, if the output is greater than or equal to 0.5, you can say it as pass. Or if the output is less than 0.5, we can consider as fail, right? It is the binary classification problem, you can know. Okay, binary classification problem. So the sigmoid activation function is used in the binary classification very well, so it is considered as pro for this. Okay, the formula for the sigmoid activation function looks like this: 1 by 1 plus e power minus x. Okay, and this sigmoid activation function will mostly used in the binary classification problems. Okay, so it's solving the binary classification problem, so we can use sigmoid activation function. It will be helpful for us. Okay, and then we if we consider the cons, like disadvantages of the sigmoid activation function, the vanishing gradient descent. This problem will arise during the sigmoid, like when we use sigmoid activation function, and because of this, like it will slowly converge. Okay, it will slowly converge towards global minima. Okay, the convergence will be slow during the entire process. Okay, the convergence will be slow. If the second activation function will be Tanh, and this Tanh is you can see it will be ranging from -1 to +1, -1 to +1. Okay, from negative and also positive. So, and you can see the curve, the S-shaped curve has 0 centered, right? You can see here 0 centered. Okay, that means it will be very useful for us, like for the negative or positive values also. So we can get the output from -1 to +1. Okay, and this hyperbolic, it is also known as hyperbolic tangent. This activation function, the formula for this is e power x minus e power minus x by divided by e power x plus e power minus x. And the pros for the Tanh activation function is 0 centered output. We can get the output, like output close to 0. Okay, close to 0 we can get the output for the tangent. While we are using Tanh activation function, we'll get the output close to 0. Okay, like whether it is in negative or positive, we will get close to the 0. So it will be very helpful for us, and it also has the same problem which sigmoid activation function faces. Okay, vanishing gradient descent. It also converges slower, right? Slowly. And in both of these activation functions, we can see the major problem, the major con is vanishing gradient descent. With because of that, the convergence will be slow, and in both Sigmoid activation function and Tanh activation function, we can see the major problem is vanishing gradient descent, right? So because of that, it slowly converges, right? So to solve this, the researchers have found the new activation function, right? ReLU activation function. This is the famous activation function in neural networks, and ReLU means a rectified linear unit, and it is very popularly used. Okay, and for this, the formula is max of 0, z. You can see here. Okay, for every input, for every negative input, it is scaled to 0. Okay, if the input is negative, it will be scaled to 0, but for every positive input, it can take. Okay, there is no problem for the positive input, but if there is any negative input, that input will be scaled to 0, whatever it may be. Okay, this is the formula for this, and you can see, and the pros is it is very efficient. This activation function is very efficient and best, like we can use activation function anywhere, like in mostly in convolution neural networks, this ReLU activation function will be used highly. Okay, and it avoids the major problem, vanishing gradient descent problem, right? Sorry, I forgot here to write vanishing. Okay, vanishing gradient descent problem, vanishing gradient descent problem. So because of this, convergence will be slow, right? But here for the ReLU activation function, there is no gradient, vanishing gradient descent problem, so there will be no problem like the slower convergence, right? So it will be fast. Okay, and there is some problem like dying ReLU. Like consider this neuron. Okay, and if the input, like if the input is 0, the value is 0, there will be a problem of like dying ReLU. That means this neuron will be dead. Okay, if the value is 0, what can it give as an output, right? So the neuron is dead. Okay, likewise there will be more neurons where the input is remains as 0 and the neuron will be dead. Okay, so this is a problem, right? Because so many neurons will be dead. This is called dying ReLU problem. There is another activation function called Leaky ReLU, and by this Leaky ReLU we can solve the dying ReLU problem, like as I said earlier, the dying neuron problem. Okay, see the formula for this, max of 0.1 x comma x. Okay, I will explain here. And if the value is greater than 0, the input will be x, right? This one. Okay, if the input value is greater than 0, there will be no problem, right? But it is positive value, so no problem. If the input value is less than or equal to 0, that means negative, it will not become 0. Why? We had some hyperparameter here called alpha. Okay, alpha. So the alpha is added to the input value, so that's the reason it will not become negative. Okay, if the given input is positive, there will be no problem. If the given input is negative, so there will be an introduction of hyperparameter called alpha. So because of this, the neuron will not be dead because the input value is not 0, right? Is not 0, so the neuron will not be in the dead state. So that's the reason. So by using Leaky ReLU activation function, we can avoid the problem, dying ReLU problem. Okay, and then there will be small con for this, like not a major con but a minimal disadvantage is alpha is a hyperparameter, so we can say it has some con for this. Okay, and we can see the slope, some slope as 0.01, like that, 0.1 or 1. And we had another activation function, which is softmax activation function, and it is zero centric. You can see the distribution for this, and S shaped curve which is passing through the origin, zero centered, and the value ranges from -1 to +1. And this softmax activation function widely used in multi-class classification problems. Okay, so you can see the advantages for the softmax is we can use it in multi-class classification. We had so many classes as output in the multi-class classification problems, so it gives the probability. Okay, which class has the highest probability, it gives that class as the output. So we can see it goes from one class to every class input. Okay, and the major disadvantage is sensitive to outliers. Okay, and in conclusion, if you got the problem as binary classification problem, so we can use ReLU in the hidden layer. Okay, so it has no gradient descent, vanishing gradient descent problem, right? So you can use ReLU. And in the output layer, we use the activation function for the all output neurons is sigmoid activation function. And as I said earlier, you know why we use sigmoid activation function? Because if you got binary classification problem, either we need we need to say yes or no, right? Two classes, yes or no, binary classification. So sigmoid will be helpful in that. It works fine, so we will use sigmoid activation function in that. If we got any multi-class classification problem statement, so in problem, so we can use hidden layer, same, we can use ReLU, there is no problem with that. And we can use softmax activation function. So as I said earlier, in multi-class classification we need to find one class only, right? To get only one class from several classes, right? So we need softmax. It works very well for the multi-class classification. If we got linear regression problem, we can use ReLU in the hidden layer, and for the output layer, linear activation function. So guys, these are all the activation functions which is used in the deep learning neural networks.